Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the anomalous behavior of the second period members in their groups. First of all, what do we mean by the word anomalous? Anomalous stands for different from others. Now let's come to the periodic table. Now in periodic table, let me mark the period number 2. This is the period number 2. Now the members of period number 2 will show properties different from rest of their group members. Now let's talk about the group number 1. The group number 1, that's alkali metals. The member of period number 2 in case of alkali metal is lithium. Now let's talk about the group number 2. In case of group number 2, the alkaline earth metals, the member of period number 2 is beryllium. Now lithium and beryllium forms the compounds with more covalent character whereas the rest of the members, now in case of the group number 1, there's sodium, potassium, rubidium, cesium, francium, and in case of the group number 2, the rest of the members are magnesium, calcium, strontium, barium and iridium. These elements forms the compounds with ionic character. So this is the first point of difference of the properties shown differently by the members of period number 2 in case of group number 1 and group number 2. On the other hand, the lithium shows the properties similar to that of the magnesium. That's called diagonal relationship. And on the other hand, we have one more diagonal relationship that's between the beryllium and aluminium. Beryllium and aluminium also shows diagonal relationship, that is the properties of beryllium and aluminium matches with each other. So now let's talk about the members of period number 2 in case of group number 13 to 17. That's boron, carbon, nitrogen, oxygen and then fluorine. Now the reason for the difference in properties in case of boron to fluorine in group number 13 to 17 is mainly the small size of the members of period number 2 in each group, the very high electronegativity and high charge to radius ratio. Now what are the properties that they are showing different? The very first thing is the orbitals which are available to get filled or to form the bonds for the period number 2 are the 2s and the 2p. In 2s subshell we have only one orbital, and in 2p subshell we have 3 orbitals, so we have total of 4 orbitals. So in case of period number 2, the members can show, members of period number 2 can show maximum covalence of only 4 because of availability of 4 orbitals, the 1 orbital from 2s and 3 orbitals from 2p. So they can form maximum bonds, or they can show maximum covalence of only 4, whereas in case of the subsequent members of the period number 3, we are available with, in case of period number 3, we are available with 3s, 3p, but also 3d. In case of s, we have 1 orbital. In case of p, we have 3 orbitals. In case of d, we have 5 orbitals. So we are total available with 9 orbitals. So the members from period number so the members from period number 3 onward can show covalence more than 4. So that's the point of difference between the properties, that the members of period number 2 can show maximum covalence of only 4, whereas the subsequent members of their group can show the covalence more than 4. Now, the members of period number 2, that's let me take a different color. The members of period number 2, that's carbon, nitrogen, oxygen, are capable of, they are capable of forming multiple bonds, that is pi bonds. For example, carbon double bond carbon, or carbon triple bond carbon, or carbon triple bond nitrogen, or nitrogen triple bond nitrogen, and so on. The members of period number 2, that is carbon, nitrogen, and oxygen, can form multiple bonds with themselves, among each other, and somewhat to the members of period number 3 also. For period number 3, let me take an example, that's carbon double bond S, or you can say phosphorus double bond O. They can form, the carbon, nitrogen, oxygen can form multiple bonds, that is pi bonds. They are called pi bonds. Carbon, nitrogen, oxygen can form pi bonds among themselves, for example carbon double bond carbon, or nitrogen triple bond nitrogen, or in between them, that's carbon double bond oxygen, or carbon triple bond nitrogen. And they can form pi bonds with the members of period number 3 also, for example carbon double bond sulfur, or phosphorus double bond oxygen. The rest of the members of the group cannot form multiple bonds or the pi bonds. So logic behind this difference in the properties of period number 2 members in their respective group well dealt with great detailed discussion in the lectures of chemical bonding. So it's just an introduction. So that's all for today. I hope you all got today's lecture. If anyone wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.